Greetings, students. Just a quick video to show you this cool app. You can see this yourself. It's H-Twins Net Scale 2. So what it does is it shows you really the size of things. So what we're starting with is 1 meter times 10 to the 0. So 10 to the 0 is 1. So that's 1 times 1. So that's 1 meter. So that's actually the diameter of this circle right here is 1 meter. So this is the screen or what you're seeing it from. And this slider down here allows you to move both in and out, depending on how you want to move. So we'll just start. Let's start going. Let's go out just to start. So this would be. So this is 1 meter times 10 to the 1. So this is 10 meters, right? So this is what things look like if it's 10 meters. There's our favorite T-Rex. And now we're going to go times 10 to the 2. So this is 1 times 10 to the 2. Oh, look at that. It's Palo Alto. So this is 100 meters, right? So this is, that's what we're looking about. There's a football field. 10 to the 3, 1,000 meters. Look at that, we have Yosemite represented, and of course the Burj Khalifa, Vatican City. And the fun thing is you can keep moving out, Rhode Island, California, great state of Texas. All right, actually I wanted to start right here, 6. So this is, I want to stop at the great state of Texas. This is 10 to 1,000. So this is the inverse of a micrometer or a micron. So this is a million meters, or 1 times 10 to the 6. Sorry, I think it's 1,000 there. So I want to point that out. And then to show you how cool this is, it keeps going out and out and out and out and out. I think there's Minecraft here too, so that's kind of fun. And you can go all the way out to the edge of the universe with cosmic background radiation. You can go back in 1 times 10 to the 0, so 1 meter here. And now we can start traveling in. You can see now we're at 2, so basically a centimeter, 100th of a meter. So this is 10 to the negative, right? This is 1,000th, so we're now at a millimeter. At a millimeter, this is a single-celled organism right here, amoeba. This is a huge single-celled organism. But then some of the larger single-celled organisms, you can see at a millimeter. Then 10th of a millimeter, you're getting to an organelle. So these are some of the largest organelles, some small cells, smaller cells. And you're just beginning to see the other organelles. And you'll note that bacteria is there, right? So here we are now, we're at 5, okay? So this would be 200 microns that we're at right now. Now we're at the bacteria level. And 6, this is 1 micron. Clearly, most of the cells are visible here. Viruses are here. And we're getting to the point now when you get to microns that you can't actually see these things because the wavelengths are too small, okay? So here we're well in the range of cells. This is how cells work. Now we're moving in, and we're getting to atoms. So there's some larger atoms here and smaller molecules. This is a water molecule. This is 10 to the 9th or 10 to the 10th, negative 10th is where we get to the atom stage. So that's 10 to the negative 10th. And then if you move much, 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 much smaller in, you're going to get to fundamental particles. So fundamental particles that we care about are protons, neutrons, and then electrons, which you're not going to see here at all. So I hope you found that kind of interesting. You can play around with that, but it's important that you get a sense of what this scale is.